So we're starting out in 2.3, and what is 2.3 about? Graphing equations of lines in what forms? Slope-intercept, and what else? Standard form. Standard form's a lot easier than you think. Okay. Alright, so we're going to do a lot of examples with just graphing stuff. And the part where it's like, in your book it'll say, and compare to the graph of y is equal to x. I'm not worried about that. You can just ignore it. Don't do it. But starting with, let's see, what is this, 2.3. Number 4, y is equal to negative x. See, I know y'all have graphed lines before, so can somebody explain to me what to do to start this graph? Y-intercept is 0. So where does that point go? Okay. And then now what happens? What is my slope? So what direction do I go then? Down, so down 1. Okay, and then I can also go up and back. Not that those are straight at all, but then you just connect it. Okay, in general, you should draw about 3 points. 3 points before you connect them, but I'm not that picky about it. Let's see. Number 8. Y is equal to negative 3x plus 2. Y-intercept is 2, so where does that go? Up 2. And my slope? Down, down 3, 1 to the right. So down 1, 2, 3, and over 1. Down 1, 2, 3, and over 1. I don't care. As you can tell, mine are not either. Okay, as long as they're relatively close. Okay, and if you're just doing increments of 1, I'm not like picky about you putting the numbers on the graph. Okay, but if you're doing something like increments of 2 or larger, then you need to at least put some on there so I can see what your increments are. So then that's like 3 through 8, but then 9 through 20 is literally the same thing. It just doesn't have the and compare part, so for us it's no different. So we'll just do a couple more of those. Do y'all remember graphing? Yeah, okay. You feel pretty comfortable with graphing overall? I mean, we're still going to do more examples, but okay. Let's see. Number 12. So 12 is y is equal to 3x minus 4. Alright, so what would this one look like? So that means it's where? Down 4. Okay, and then now what? Okay, it rises, so it's 1, 2, 3, and over 1. 1, 2, 3, and over 1. And just connect the dots. Alright, so then what happens if I have one like this? 16 f of x is equal to negative 5 over 4 x plus 1. Still graphing a line. Okay, so where does my y-intercept go? Okay, what is my slope? It's falling, yes. How many do I go down and how many do I go over? Yep, down 5 over 4, so down 1, 2, 3, 4, 5, and then over 1, 2, 3, 4. Okay, I can also, just as a refresher, I can also go up 5 and back 4. Okay, so that way it all like fits on my graph that I drew. And then just connect the dots. I don't care how straight your line is, though it should be relatively straight. How do we feel about this? Do we need to do any more? We're okay with that kind. I just wanted to make sure that we knew what to do with a slope that was like a fraction, so that we remembered how to do that. Let's see. Alright, so then the next one's jumping down to 24 through 29. Say to find the x and y intercept of the line with the given equation. So, 24, x minus y is equal to 4. Alright, so with these ones, okay, these are the ones that are in standard form. Okay, we're not actually graphing these, you're just purely telling me the x and y intercepts. Do you remember what method that I referred to in the video? Okay, yep, the cover-up method. Did you guys do that with my mom? So you're essentially just making one of the variables 0, okay? By doing that, I just literally cover it up. So that means x is equal to 4. Yes. Super easy. No, we're also doing y. Okay, and then, what is y then? Y is negative 4. Okay, so if I were to be graphing it, that's the points I would use to do it. Okay, officially we should write this as the x-intercept is 4, y-intercept is negative 4. Okay, that's officially how your book writes the answers, which is the way it should be written, because technically this is a line. This is saying the intercept here. But that's what you get when you do the cover-up officially, which will help you to graph it if you, I don't know if the book actually has you graph them at any point. It looks like, yeah, it looks like you do. So, let's see, another one. (28) 4x minus 5y is equal to 20. Alright, so using the cover-up method, what is x equal to? X is equal to 5, so my x-intercept is 5. How about y? Y is equal to negative 4, so then our y-intercept is negative 4. Okay, so that's your answer there in the box. Do we need to see any more of those? Okay, so when we go to graphing them, that's the next thing we're getting ready to go to. Okay, when we graph these, we literally just plot these 2 points here on the axis. The x-axis, we're plotting 5. On the y-axis, we're plotting -4, okay, for this one, and we just connect the dots. So it's super easy. So you may not have liked it before, but hopefully now you see why. It's actually really nice, and hopefully you like it more. You don't have to count slope. All right. So moving on to the graphing ones. Graph the equation, label any intercepts. Okay, so the first thing I would do is write the intercepts like we just did, and then graph it, just because I feel like it's kind of backwards to do it the other way. 32. 2x minus 6y is equal to -12. So first of all, what are my intercepts? Yep, and then y is +2. And then now I can come over. Okay, so now on my graph, I go to -6 on the x-axis, and I plot a point. On the y-axis, I go up to 2, and I plot a point. Connect the dots, and I'm done. Okay, is that easier than counting slope? Yeah. Yes. Same thing we just did in the last thing. So you cover them up. So 2x is equal to -12. X is equal to -6. And then over here, if I cover up x, then -6y is equal to -12. Divide by -6, so y is equal to +2. Yep, because essentially what you're doing is you're setting the variables each individually equal to 0. So rather than writing out, okay, 2 times 0 minus 6y is equal to -12, you're just saying, okay, I know that's going away, so I'm covering it up and getting rid of it. And then you can just do it without actually having to do a lot of work. How about 34, y is equal to -2. What is that line going to look like? Horizontal line at -2. Okay, so we don't even have to do anything with this other than at -2, I draw a line. Super easy. Just as a refresher, what slope would this have if it were to ask you that? 0 slope. Let's see. Let's do one more of these ones. 38, -x minus y is equal to 6. So what would my x-intercept be? -6. Y-intercept is also -6. Okay, by covering them up and solving for them. So then what is my graph going to look like? Yep. Over here, over here. And I definitely just missed that second point, but that's okay. Any questions about this type? Do we need to do any more? Feel okay about it? All right. So then 43 through 54 say to choose any method to graph them. So basically, if it's already in this form, I would say graph it using the cover-up method. If it's written any other way, I would probably do it in y equals mx plus b, but technically you can do any of them any way that you like. So let's do one or two of those. Let's look at one that could be done either way. 52. 14 minus 3x is equal to 7y. All right, recommendations on what method I should use here. Berkeley, what do you say? Standard form, Taylor? Standard form, Joelle? Standard form, everybody wants standard form? Okay. So we could switch and do this one in y equals mx plus b. Since everybody wants standard form, I'm going to show you this one first. I'm not actually going to graph it this way, but I'm just going to show you how to solve it, just to make sure we are okay with it. Okay, so if I were to do it in y equals mx plus b, I would just divide everything by 7. So I would get y is equal to 14 divided by 7 is 2 minus 3 over 7x. Okay, and then I would rewrite it as negative 3 over 7x plus 2. Okay, that's in slope-intercept form, but you guys like standard form. I think it's easier, so it's like, why not do it? How would I set it up in standard form then? Yes. That's one way we can do it. So we can move the 7y over and then move the 14 to the other side. So negative 3x minus 7y is equal to negative 14. Okay, another way I could write it is I could have added the 3x over to make everything positive, and then I could have just had 3x plus 7y is equal to positive 14. Okay, in any of these forms here are acceptable. Okay, all of those are acceptable answers. They're the way you can, it's really up to preference for how y'all want to write it. So then what are my intercepts for standard form? What's my x-intercept? I think you're right. Wait, 14 over 3, well, 2/3. So it would be 14 over 3, which these, if you want to write them as a mixed number since you're graphing them, it'll be easier. It would be 4 and 2/3. Okay, and then the y-intercept. Two. Okay, so then to graph it, and then where do I put my points? Two, and then just connect the dots, and that's all you have to do. Do we need to see another one of that, or do y'all feel okay with moving stuff around and being able to graph it from there? Yes. So, yeah, we can, let's look at that one really quick. So with 44, we have negative 3 plus x is equal to 0. So what I would recommend doing, yes. It is, yep. So there's going to be a vertical line. Okay, so we're going to move the 3 over. So x is equal to 3. And then we can just graph a vertical line at x is equal to 3, and it's going just up and down like that. It's okay. What kind of slope is that? Undefined. Any more questions? Feel okay about this stuff? Alright. Then your problems. And you'll have a little over 25 minutes to work on them. So you should be able to knock these out. Alright, so 3, 9, 13, 17, 25, 29, 37, 43, and 47. If you have a question, obviously I'll come around and help you as needed.